From our previous classes, we have learned a lot about chemical formulae. Today, we're going to advance a little bit and learn about chemical equations. A chemical equation is a representation of a chemical change or reaction. It shows the chemical formulae of the reactants, products, and their proportions. Let us begin with the common example that we already know of hydrogen reacting with oxygen to give us water. Now, hydrogen and oxygen are known as the reactants, while water is the product. Now, for us to write the chemical equation for this reaction, we need to write the chemical formula for hydrogen, the chemical formula for oxygen, and the chemical formula for water, like this. H2 represents hydrogen. However, we do not just write the symbol H because hydrogen gas exists in a diatomic molecule. And therefore, we add oxygen, which is O2, to give us water that we already know how to write as H2O. Now, there are a little bit more details that you need to learn. Apart from writing the chemical formulae or symbols of the elements and compounds, we need to write the state symbols. Back in Form 1, you learned there are three states of matter. We have solid state, we have liquid state, and we have gaseous state. We also have another state that is known as aqueous state, even though it is not a state of matter, but it is a state that we usually write in chemical equations. So for solid state, we represent it by a small letter s in brackets. For liquid, is a small letter L in brackets. Similarly, for gas is a letter G in brackets, and aqueous state is represented by the letters A, Q in brackets. So, let us continue writing this equation. Hydrogen is a gas, therefore we write G superscript just below and after the formula. Oxygen is also a gas, we write letter G. Water is a liquid, and therefore we write small l. As you can see, we have already started writing a chemical equation that is represented right here. This equation is not yet complete, and we'll have our balancing friend right here. Very sad, because the equation is not balanced. Now, for us to balance this equation, we will need to understand that for a chemical equation to be balanced, the number of atoms in the reactant side and the number of atoms on the product side must be equal. Let us begin with hydrogen. On the reactant side, hydrogen atoms are 2. On the product side, hydrogen atoms are 2. So there is no problem with hydrogen atoms. oxygen atoms, however, are only 2 on the reactant side and only 1 on the product side. That means they are not balanced. That is why our balancing friend is not happy. Now, for us to balance oxygen, we will need to make sure that the number of oxygen on the reactant side is the same as the number of oxygen on the product side. In this case, we are going to add a 2 before the water molecule, like this. This means that now hydrogen are 2 times 2, while oxygen are 2 times 1. Remember, we do not write 1 below oxygen because the O represents 1. So indeed now we have 2 oxygen molecules on the product side, which are balanced with the ones on the reactant side. However, we have upset the equation. Now we have 4 hydrogen atoms. For us to balance this equation, we need to make sure that the reactant side has 4 hydrogen atoms. We can achieve this by adding a 2 before hydrogen, and therefore we will have 2 times 2 hydrogen atoms to give us 4. So now we have 4 hydrogen atoms on the product side and the reactant side. We also have 2 oxygen atoms on both the reactant and product side. That brings us to our balancing friend, who will now be very happy, and therefore this equation is balanced. Well, let us use a second example. Back in the topic of air and combustion, we carried out an experiment. The experiment involved heating copper in order to determine the percentage of air that is used when heating copper. At the end of the experiment, we wrote the following equation. Copper reacts with oxygen to give copper 2 oxide. Now, let us write the formula of copper. The formula of copper is Cu. And what about oxygen? It is a diatomic molecule, and therefore we write O2. And the product is copper 2 oxide. We write it as CuO. I hope you've been practicing on how to write formulas. Now the next step is to write the state symbols. Now the state symbol for copper is solid state, because it is a metal and it is a solid. For oxygen, it is a gas, therefore it is gaseous state. The product was a black solid, and therefore it is a solid. The next step is to balance this equation. The number of copper atoms on the product side is 1, since Cu represents 1. On the product side, it is also 1. However, oxygen on the reactant side are 2 atoms, while on the product side is only 1. We will achieve balancing oxygen by adding a 2 before copper 2 oxide. This would mean that now we have 2 times 1 copper atoms, which are 2 copper atoms. It also means we have 2 times 1, which equals to 2 oxygen atoms on the product side. And here we have 2 oxygen atoms. Therefore, oxygen atoms are balanced. But now we have upset the equation by having 2 copper atoms on the product side and only 1 on the reactant side. So we balance it by adding a 2 before copper. And therefore now we have 2 copper atoms. And therefore our equation is balanced and our balancing friend is very happy. Another example is the reaction between zinc and hydrochloric acid. Which gives us zinc chloride and hydrogen gas. Now for us to write this equation, it is going to be simple. Zinc is written as Zn, reacting with hydrochloric acid, which is written as HCl, to give us the product zinc chloride, which is written as ZnCl2, and hydrogen gas, which is H2. For the state symbols, zinc is a solid, hydrochloric acid is aqueous. Remember this state? Zinc chloride is also aqueous, while hydrogen is a gas. In order to balance this equation, we need to look at the number of atoms of each element. On the product side, we have zinc, 1 atom of zinc. On the reactant side, we have 1 atom of zinc. We have only 1 atom of hydrogen, but 2 atoms of hydrogen. And therefore, we balance it by adding a 2 before hydrochloric acid. And now we have 2 times 1 equals to 2 hydrogen atoms. And therefore, hydrogen atoms are balanced. Similarly, chlorine atoms are now 2 times 1 chlorine atoms. And on the product side, we also have 2 chlorine atoms. And therefore, chlorine atoms are also balanced. And hence, this equation is balanced. In order to write the final equation, we just write zinc reacting with hydrochloric acid to give us zinc chloride and hydrogen gas. Zinc chloride is aqueous, and we just add a 2 before hydrochloric acid, and the equation is balanced. Carry out more practice with different equations. for you to perfect your skills on writing and balancing chemical equations.